Good morning, students. In the first video, I have discussed about the preparation of amines and nomenclature of amines. In this video, I am going to discuss about. In these videos, I am going to discuss about the physical properties and chemical properties of amine. So let's start. First, physical properties of amines. Physical properties of amines means their boiling point, melting point, their smell. Okay, and solubility in water. Lower aliphatic amines are water soluble because they can form hydrogen bonds with water molecule. However, the solubility decreases with increase in hydrophobic alkyl group. Okay. Similarly, the boiling point of primary amine is greater than secondary amine, greater than tertiary amine. This is due to intermolecular hydrogen bond formed between the amines molecule. And basic strength, main physical property, the main physical property of amines is basic strength of amine. Amines are basic in nature. Amines are basic in nature due to presence of lone pair on nitrogen. And aliphatic amines, that is RNH2, C2, CH3NH2, methylamine, ethylamine are these are aliphatic amines are stronger bases than ammonia. This is because aliphatic amines contains alkyl group, and alkyl group has electron releasing effect, that is plus I effect. And due to electron releasing effect, plus I effect of alkyl group, aliphatic amines are stronger bases than ammonia. And also aliphatic amines are stronger bases than aromatic amine. Okay, and the basic strength of aliphatic amines in gaseous medium is 3 degree amines greater than 2 degree amines greater than 1 degree amine. But in aqueous solution, the basic strength of different aliphatic amines are showing here. Generally, in aqueous solution, 2 degree amines are strongest based. Generally, in aqueous medium, the 2 degree amines are strongest base. Okay, so in case of ethylamine, the in aqueous solution, in case of different ethylamines, the order of basic strength is 2 degree ethylamine greater than 1 degree, or 2 degree ethylamine greater than 3 degree ethylamine greater than 1 degree ethylamine greater than ammonia. In aqueous solution, basic strength of different ethyl amines is in the order 2 degree ethylamine is greater than 3 degree ethylamine is greater than 1 degree, or primary ethylamine greater than ammonia. And in case of methylamine, in case of different type of methylamines, the basic strength in aqueous solution is 2 degree methylamine is greater than 1 degree methylamine is greater than 3 degree methylamine is greater than ammonia. So in both the cases, 2 degree amines always have the highest basic strength. So 2 degree amines are strongest base in aqueous solution. Okay, you have to remember the order of basic strength of different types of ethylamine and methylamine in aqueous solution. But in a gaseous state, the order of basic strength is always tertiary amine has the highest basicity or basic character in gaseous medium. Tertiary amine greater than secondary amine greater than 1 degree amine, or primary amine. And aromatic amines are weaker base. Aromatic amines are weaker bases than aliphatic amine. This is due to the fact that the electron pair on the nitrogen atoms of NH2 group of amine. This is due to the fact that the lone pair on nitrogen atom of nitrogen atom of NH2 group is involved in resonance with the pi electron of benzene ring. So the aromatic amines are weaker base aromatic amines like benzenamine or aniline, N,N-dimethyl and N,N-dimethyl aniline, these are weaker bases than any aliphatic amine. And if electron releasing group like CH3, OCH3, NH2, these are present in the benzene ring of aromatic amine, this group increases the basic strength of aromatic amine. Electron releasing groups like CH3, OCH3, NH2, this group, if this group are present in the benzene ring of aromatic ring, uh, then the basic strength of aromatic amine will be increased. And while electron withdrawing groups such as NO2, halogen, cyanide, if these groups are present in the benzene ring of aromatic amine, then these groups will decrease the basic strength of aromatic amine. So when electron releasing groups are present in the benzene ring, then the basic strength of aromatic amine will be increased. And if the electron withdrawing groups are present in the benzene ring of aromatic amine, then the basic strength of aromatic amine will be decreased. Now chemical properties of amines. Chemical properties of amines. First chemical property is alkylation, means reaction with alkyl halide, reaction of amine with alkyl halide. So when amine react with alkyl halide, it will form, if primary amine react with alkyl halide, it will be converted into secondary amine. If secondary amine react with with alkyl halide, it will converted into tertiary amine. Okay, so all the three types of amines react with alkyl halide to form quaternary ammonium salt as the final product, provided alkyl halide is present in excess. Okay. Second type of reaction, acylation. Acylation means reaction with acetyl chloride or reaction with acetic anhydride. Reaction with acetyl chloride, CH3COCl, or reaction with acetic anhydride, CH3COOCOCH3. This is an acetic anhydride, CH3COOCOCH3. So reaction of amine with acetyl chloride. When amine reacts with acetyl chloride, the Cl of acetyl chloride, the chlorine of acetyl chloride will combine with one hydrogen atom from amine, and it will be removed as HCl, and you have to join the remaining part of these two molecules, that is C2H5NHCOCH3. C2H5NHCOCH3, it will be converted into amide. Okay, just remove one HCl molecule from amine and acetyl chloride. Okay, similarly, when amines react with acetic anhydride, you have to remove here, you have to remove one hydrogen atom from amine, from NH2 group, and the acetate group from acetic anhydride, and join this to one H from amine and the CH3COO minus acetate ion from acetic anhydride, and join them and remove as acetic acid, and join the remaining part, that is C2H5NH COCH3, C2H5NH C2H5NH COCH3, it will be acetanilide. So by acylation reaction, of amine converted into amide. Next, benzylation. This is a similar reaction. Benzylation reaction means a reaction of amine with benzoyl chloride, C6H5COCl, benzoyl chloride. Just the solvent in this reaction, the solvent is pyridine. Okay, when methylamine react with benzoyl chloride, C6H5COCl, in presence of pyridine, the product will be CH3NHCO C6H5. Just remove one HCl molecule from CH3NH2 and C6H5COCl and join the remaining part. Remove one Cl and one hydrogen from CH3NH2 from amine and join the remaining part, that is CH3NH C6 CH3NH CO C6H5. Okay, that is benzylation. This is the benzylation of aniline is known as Sorten-Baumann reaction. This reaction is also known as Sorten-Baumann reaction. Benzylation of aniline. If the amine is aniline, if the amine is aniline, that is C6H5NH2, when aniline reacts with benzyl chloride C6H5COCl, then the product will be C6H5NHCOC6H5, and this reaction is known as Sorten-Baumann reaction, benzylation of aniline. Okay, just remove one HCl molecule and join the remaining part. Next reaction, and it is a important reaction, carbyl amine reaction. Carbyl amine reaction of 1 degree amine. Carbyl amine reaction of 1 degree amine. So in carbyl amine reaction, amines reacts with chloroform and KOH. The reagents are chloroform and KOH. 1 degree amine react with chloroform in presence of KOH, basic medium. It will be converted into isocyanide, alkyl isocyanide. Amine will be converted, the NH2 will be converted into NC group. When amines react with chloroform in KOH, if you heat a mixture of 1 degree amine with chloroform in KOH, you will get alkyl isocyanide RNC. The NH2 group will be converted into NC. NH2 group will be converted into NC. That is amine will be converted into isocyanide, alkyl isocyanide, plus KCl and 3H2. The KCl and 3 water are side product. Okay, and the main product is RNH2. So if you react methylamine CH3NH2 with chloroform in KOH, then the product will be methyl isocyanide, that is CH3N triple bond C. And alkyl isocyanide has a bad smell. Alkyl isocyanide, a bad smelling compound. Okay, so by carbyl amine reaction, you can identify, using this carbyl amine reaction, you can identify 1 degree amine or primary amine, because primary amine, when react with chloroform and KOH, it will produce a bad smelling compound which is alkyl isocyanide. Next, reaction with acid, nitrous acid. Reaction of amine with nitrous acid. So first, nitrous acid means HNO2, and when alkyl amine, when amine RNH2 react with amine, when amines react with nitrous acid, that is HNO2, it will be converted into alkyl diazonium salt Rn2 plus Cl minus. When amine primary amine reacts with nitrous acid are not directly used in this reaction. Generally, soda NaNO2 plus HCl, sodium nitrite and HCl solution is used, which produce HNO2, because HNO2 is a highly unstable substance, and any HNO2, that's why HNO2 is not directly used in this chemical reaction. And in this chemical reaction, you have to react sodium nitrite, NaNO2 and HCl. It will produce HNO2, and then HNO2 reacts with RNH2 amine, and amine will be converted into alkyl diazonium salt Rn2 plus Cl minus. And on hydrolysis, the alkyl diazonium salt will be converted into alcohol ROH. So when amine aliphatic amine reacts with when aliphatic amine reacts with nitrous acid HNO2. HNO2 means NaNO2 in HCl. HNO2 means NaNO2, you have to write NaNO2 plus HCl. It will produce HNO2, and then HNO2 will react with amine RNH2, and the RNH2 group will be converted into RN2 plus Cl minus, and into alkyl diazonium salt RN2 plus Cl minus. These are very unstable substance, and on hydrolysis alkyl diazonium salt will be converted into alcohol finally. So aliphatic primary amine on reacting with nitrous acid HNO2, it will be converted into alcohol. For example, if methylamine CH3NH2 react with HNO2, it will be finally converted into methanol CH3OH. But aromatic amine are aromatic benzene diazonium salt are very stable. When aniline reacts, when aniline, that is aromatic amine C6H5NH2 reacts with nitrous acid, that is NaNO2 plus HCl at very low temperature 0 to 5 degrees Celsius or 273 to 278 Kelvin temperature. When aniline reacts with nitrous acid, it will be converted into benzene diazonium salt, and aromatic diazonium salts are very stable. That's why this benzene diazonium chloride will not be converted into alcohol. Aliphatic diazonium salts are unstable, and that's why they will be converted easily into alcohol. But aromatic diazonium salt like benzene diazonium salt are very stable compound. That's why benzene diazonium chloride will not converted into phenol, into alcohol. But secondary and tertiary reaction amines reacts with nitrous acid in different manner. Okay, and reaction with aryl sulfonyl chloride, that is benzene sulfonyl chloride. Benzene sulfonyl chloride, the formula and structure of benzene sulfonyl chloride given here. Benzene ring H double bond O Cl. This benzene sulfonyl chloride, it is also known as Hinsberg reagent. And this Hinsberg reagent, using this Hinsberg reagent, you can identify amine, whether it is a primary or secondary or tertiary amine, or you can separate a mixture of primary, secondary and tertiary amine using Hinsberg reagent. So Hinsberg reagent, that is benzene sulfonyl chloride, when reacts with primary amine, this is the primary amine C2H5NH2, it will be converted. Just remove one HCl molecule from Hinsberg reagent and primary amine, and it will be converted into water, into alkali soluble compound. When Hinsberg reagent reacts with primary amine, this will produce N-alkyl, that is N-ethyl benzene sulfonyl amide. If the alkyl group is ethyl, then it is N-ethyl. If the alkyl group is methyl, then it is N-methyl benzene sulfonyl amide. And this is soluble in alkali. The benzene sulfonyl amide produced from primary amine are soluble in alkali. But if benzene sulfonyl chloride reacts with 2-degree amine, this is a 2-degree amine, N-ethyl ethanamine. Okay, if benzene sulfonyl chloride reacts with 2-degree amine, similar reaction will be there. One HCl molecule will be removed, and it will be converted into insoluble in alkali. It will be converted into the product NN diethyl benzene sulfonamide, NN diethyl benzene sulfonamide, which is insoluble in alkali. That is, the reaction of benzene sulfonyl chloride with secondary amine yields NN diethyl benzene sulfonamide, which is insoluble in alkali. But the same product produced by primary amine, which is soluble in alkali, and tertiary amine does not react with benzene sulfonyl chloride. So using benzene sulfonyl chloride or Hinsberg reagent, you can differentiate a mixture of primary, secondary and tertiary amine. Next, electrophilic substitution reaction of amines. Electrophilic substitution reaction. Aniline, this is a main reaction of aromatic amine. Electrophilic substitution reaction of aromatic amine. Aniline is the orthopara directing. Aniline means in aniline NH2 group is directly attached with benzene ring, and NH2 group is orthopara directing group. In aniline, aniline is orthopara directing towards electrophilic substitution reaction due to high electron density at ortho and para position. So the reaction of aniline with bromine water, reaction of aniline with bromine water, it will produce, this is an electrophilic substitution reaction of aniline with bromine water, Br2 water, it will produce 2,4,6 tribromoaniline. The product is, this is a very important reaction of aniline with bromine water, the product is 2,4,6 tribromoaniline. Okay, 3 bromine will be entered into the ortho and para position, that is 2, 4 and 6 position. So when aniline reacts with bromine water, it will produce 2,4,6 tribromoaniline, and 2,4,6 tribromoaniline is a light yellow precipitate. So to prepare monosubstituted derivative, that is only orthobromoaniline or only parabromoaniline, to prepare monosubstituted derivative, activating effect of NH2. NH2 is a highly activating group. That's why we are getting this product. Substitution on substitution at ortho and both ortho and para position, that is 2,4,6. Okay, due to high activation power of NH2 group. And if you want to prepare monosubstituted derivative, activating power of NH2 group must be controlled, and it can be done by protecting the NH2 group, by acetylation. So if you want to get monosubstituted product, you have to control the activating power of NH2 group, and activating power of NH2 group can be controlled by protecting NH2 group by acetylation with acetic anhydride. So when aniline reacts with acetic anhydride, in pyridine, CH3CO whole twice O, this is acetic anhydride, CH3CO whole twice O, this is acetic anhydride. So this acetic anhydride reacts with NH2 group of aniline, and it will be converted into acetanilide. And now react this acetanilide, this is acetanilide, react with bromine in acetic acid, then you will get only para substituted bromoacetanilide. And on hydrolysis, then only on hydrolysis this para substituted acetanilide will be converted into para bromoaniline. Okay. Next, nitration. If you uh, react aniline with nitric acid and sulfuric acid, mixed acid. It is also called mixed acid, mixture of concentrated nitric acid and sulfuric acid. Mixture of concentrated nitric acid and sulfuric acid is known as mixed acid. Huh. Aniline, when reacts with mixed acid at 288 Kelvin, it will be converted into para-nitroaniline, meta-nitroaniline, and ortho-nitroaniline. Para-nitroaniline 51%, meta-nitroaniline 41%, and 2% ortho-nitroaniline. Okay, and if you want to get only monosubstituted nitroaniline, then you have to protect the NH2 group by acetylation. If you want to get only monosubstituted nitroaniline, that is para-nitroaniline, then you have to protect the NH2 group by acetic anhydride. So when aniline reacts with acetic anhydride in presence of pyridine, it will be converted, the NH2 group will be converted in NHCOCH3 group. This is the protection of NH2 group. And in the next step, you have to use mixed acid, nitric acid and concentrated sulfuric acid, mixture of nitric acid and concentrated sulfuric acid. And by the reaction, the product will be para-nitroacetanilide. And on hydrolysis, this product will be converted into para-nitroaniline. Okay, these are electrophilic substitution reaction of aromatic amine. Now see benzene diazonium chloride. This is another type of compound. Benzene diazonium chloride formula is C6H5N2 plus Cl minus. C6H5N2 plus Cl minus. Benzene diazonium chloride. Preparation, I have told this preparation of benzene diazonium chloride, diazotization reaction. When aniline reacts with HNO2, that is NaNO2 plus HCl, it will produce HNO2 nitrous acid. When aniline reacts with NaNO2 in HCl at 0 to 5 degrees Celsius, that is 273 Kelvin to 278 Kelvin, it will be converted into C6H5N2 Cl, benzene diazonium chloride. When anilines react with NaNO2 in HCl, NaNO2 sodium nitrite plus HCl, that is actually nitrous acid, HNO2. It will produce NaNO2 plus HCl will produce HNO2, and HNO2 will react with aniline, C6H5NH2, and it will be converted into benzene diazonium chloride, C6H5N2 plus Cl minus. Okay, and you have to read about the properties and chemical properties of benzene diazonium chloride. And benzene diazonium chloride is actually a stable compound due to resonance. Benzene diazonium chloride, here resonance structure of benzene diazonium chloride is showing, and benzene diazonium chloride is actually a resonance stabilized. Benzene diazonium chloride actually a resonance stabilized aromatic compound. Okay, and you have to read about the chemical properties of benzene diazonium chloride. When benzene diazonium chloride C6H5N2 plus Cl minus reacts with a hypophosphorus acid, that is H3PO2. When benzene diazonium chloride reacts with hypophosphorus acid H3PO2, it will be converted into benzene C6H6. Which reaction you have to read, I have marked in the PDF. Okay, when benzene diazonium chloride reacts with hypophosphorus acid, it will converted into benzene C6H6. Okay, and when benzene diazonium chloride reacts with CuBr HBr, it will converted into bromobenzene. When benzene diazonium chloride reacts with CuBr in HBr, it will be converted into bromobenzene. And this is known as Sandmeyer reaction. When benzene diazonium chloride reacts with benzene diazonium chloride C6H5N2 plus Cl minus reacts with CuCl HCl or CuCl, CuBr, HBr, they will produce chlorobenzene or bromobenzene like this. Chlorobenzene, bromobenzene, these are known as Sandmeyer reaction and Gattermann reaction. If benzene diazonium chloride react with copper in HCl, benzene diazonium chloride C6H5N2 plus Cl minus reacts with copper in HCl or copper in HBr, then these two reactions are known as Gattermann reaction. Okay, and the product will be chlorobenzene or bromobenzene. And when benzene diazonium chloride reacts with water, it will be converted into phenol. Benzene diazonium chloride reacts with water, it will be converted into phenol, C6H5OH. The main product is phenol. And coupling reaction is the important reaction of diazonium salt. Benzene diazonium salt react with phenol in basic medium, it will produce a orange dye, orange colored dye. And the formula structure of the compound is para-hydroxy azobenzene. When benzene diazonium chloride react with phenol, when benzene diazonium chloride reacts with phenol in basic medium, that is pH 9 to 10, it will converted into para-hydroxy azobenzene. Okay, the structure given here, and the color of this compound is orange, orange dye. Okay, and similarly coupling reaction with aniline. When benzene diazonium chloride reacts with aniline C6H5NH2, similar types of coupling product will be formed, and color of this coupling product is yellow dye. So para amino azobenzene is formed when benzene diazonium chloride reacts with aniline. The structure is given here. You have to practice the all the structure and all the reactions which I have marked. Okay student, thank you.